So this is a quick little video on how to factor quadratics in different forms. So what you're looking at is 3 different quadratics, and they are all in a slightly different form. So the first 2 are written as a quadratic trinomial. So that means we have an x squared, we have an x, and then we have a constant that is not 0. And so both of the first 2 are trinomials, and we're going to talk about how we factor trinomials. The thing to notice about the difference between the first and the second one is that there is not a number in front of the x squared on the first one. So that means that we have a 1 there, and it makes it slightly easier to factor. The second one, we have a 2 in front of the x squared, which means it's still a trinomial, but we have to deal with that too. And the third one, you'll notice we have an x squared and an x, and then we don't have that constant that the other 2 have. So we're going to talk about that one last, of how we would factor that. So the first thing is they're not always going to be set equal to 0. So if I'm looking at this, I notice I have an x squared minus 2x equals 48. So the first thing I'm going to do is I'm going to get everything onto the same side and set equal to 0. So that would give me x squared minus 2x minus 48 equals 0. So like I said, this is the easier of the 2 trinomials to factor because we don't have a number with the x squared. So for this, all we have to do is say what numbers multiply to my c value, or the negative 48, and they add to negative 2. So I'm looking for factors of negative 48. So I know that 8 and 6. So I can say negative 8 and positive 6. Those would multiply to negative 48, and they would add to negative 2. So that gives me factors of x minus 8 times x plus 6. And then those are the factors. If I want to find the solutions or the zeros, I can set each of those equations equal to 0 because of the zero product property. So I can say x minus 8 equals 0 and x plus 6 equals 0, which gives me x equals 8 and x equals negative 6. So now with our next one, we have a number in front of the x squared. So that means it is still a trinomial, but we are going to have to factor it a little differently. First of all, I don't like to deal with a negative x squared value. So it's easiest if we get everything over to one side, and it's easiest to make that x squared positive. So I'm going to put 0 on the left, and I'm going to move everything over to the right. So if I add 2x squared, that's going to make a positive 2x squared. I'm going to have to subtract 7x, and I keep that negative 15 over here. Okay, so because I have that number in front of the x squared, this is where we're going to have to use a different strategy to factor the trinomial. So the easiest strategy that I have found is the area model. So I'm going to make a 2x2 box. I'm going to put my first term, 2x squared, in the upper left, and I'm going to put negative 15 in the lower right. Then I'm going to multiply those 2 numbers together. So if I multiply those 2 together, I get negative 30 x squared. So I'm looking for, similar to the last example, I'm looking for 2 numbers that multiply to negative 30, but they need to add to that middle term, which is negative 7x. So I'm thinking of 30. I think of my factors of 30. That could be 2 and 15. It could be 3 and 10. It could be 5 and 6. And I know that one of them needs to be negative because they've got to multiply to a negative 30. And I know that they need to add to negative 7. So I want the 3 and the 10, and I want to make the 10 the negative because I need them to add to negative 7. So I'm going to put those 2 terms in either one of the spots. It doesn't matter where I put it. So I'm going to put the 3, and I'm going to add an x, and the negative 10x. And now what I'm doing with my area model is I'm finding the greatest common factor in each row and column. So if I start with the first column, I have 2x squared and 10x, negative 10x. So if I look at that column, I think, okay, 2 goes into both 2 and 10, so I can take out a 2, and they both have an x. Then if I look at this column right here, 3x and negative 15, I know that 3 goes into 3 and 3 goes into 15. So I'm going to take out a 3. Now I'm looking at the first row. I have 2x squared and 3x. They have an x in common. And then I have negative 10x and negative 15. They both have a negative 5 that goes into both of them. So what that means is my factors are 2x plus 3 and x minus 5. And I'm getting that from here and here. And just like the previous one, if I want to find the solutions or the zeros, I can set each of those parentheses equal to 0 and solve. Now our last one, we don't have a constant. So something that people want to do sometimes is they want to divide, but sometimes if we divide, we lose potential answers, especially when we're solving something that is quadratic in a quadratic form, but not necessarily a quadratic equation. So what I want to do on this is I want to get everything over to the same side, similar to the last two. So here I have 2x squared. I'm going to subtract the 4x to the left and set that equal to 0. So I'm missing a constant on this one. So I can't factor this the same way that I did the previous two. On this one, I notice that 2 goes into both 2 and 4. So I can factor out a 2. And then I know that they both have an x. So I can take out an x as well. So if I take 2x squared and I divide out a 2x, I'm left with just an x. And if I take 4x divided by 2x, I'm left with just a 2. And so that's how I would factor this. And then similarly, I can solve by setting 2x equals 0 and x minus 2 equals 0. A good way to check on this, if you did it right, is you can always distribute that 2x back in and check. If I distribute it, I get 2x squared minus 4x. And you can see that that is the original, oops, right down here that I had. So those are the three main ways that we're going to factor quadratics, and hopefully that helps.